electromagnetic energy systems. This research has all been suppressed by the American Medical Association, by Morris Fishbein, who also tried to suppress all of the reports and scientific publications from the Rife Research Laboratory. The principal publications of the microscope and of the research on cancer and many other diseases was published by the Smithsonian Institution and by the Franklin Institute in 1944. Copies of this document will be made available for any person wishing to secure one. Rife was demonstrating here that 5 frequencies could be put on the same carrier wave, which was unheard of at that time. The person that benefited from this was a telephone company, and today I understand they're using over 100 frequencies on the same carrier wave. This work was in conjunction with Coolidge of General Electric, who furnished the ray tubes. This is a picture of the interior of the laboratory of John F. Crane in San Diego. Years later, in which the instruments were set up again to do further research from 1950 to the present time. This is an optical bench, Bosch and Lomb, for studying metallograph work and also bacteria work. This is a Leitz optical bench in which the microscope could be put over that. It could be either horizontal or vertical, and was mounted on springs so it would be free of the Earth's shocks. This is a petrographical micropolariscope used by Rife for chemical analysis and for observation of the bacteria and virus, which was transmitted up through the 40-inch bellows of the Leitz optical bench so that photomicrographs could be made of the bacteria and other entities. This is a number 2 microscope. This is a number 4 microscope built by Rife and his assistants. Rife was a great machinist, had a tool and die maker working with him at all times. These are the controls of the instrument. That's a fine adjustment and the coarse adjustment on the top and the back. I'm demonstrating these controls to see them. This instrument was a loop which was wound for the neon or argon or krypton or xenon gases so that the test tubes could provide radiation to get the cancer virus virulent. This is a counter-rotating Risley prism in which the rays of the light were transmitted up through the instrument to stain the virus with the frequency of light. Now, this is a view of the close-up view of the Rife universal microscope, showing the dark field illuminator on the right side, which swung down into position for dark field illumination of syphilis bacteria and other dark field bacteria. Rife researched all of the bacteria, including Streptococcus, Staphylococcus, Streptothrix, leprosy, tuberculosis, gonorrhea, Streptothrix, and many other diseases. The microscope was also used for measuring the angles of crystals in crystallography. As you can see, it can be rotated through 3 planes, and the slide can be moved back and forth, up and down, in and out, and whatever angle it needed to be measured could be measured with a protractor indicator on the back of the microscope at the top, which was also coordinated with the angles of the movements that you just saw. The lights underneath the base of the microscope could be moved back and forth to use different types of light, such as infrared, ultraviolet, monochromatic beam light, and any other light that was desired. The microscope had prisms that went through both sides of it. This is the patented Rife microscope lamp, which took an ordinary automobile 21 candle power bulb and boosted it up to 1200 candle power with the reflector on the bottom, which you see there, and the condenser lens at the top of the unit. This is a Van Leeuwenhoek hanging drop microscope, first developed in around 1600 by a Dutchman in Europe, in which he could see large bacteria like paramecium and other units of microorganisms. This is the original research instrument, which changed the ohms from 100,000 ohms to 1,000,000 ohms in steps of 1 ohm to vary the frequencies used in this ray tube, which you're seeing here now. This is the inside of the ray tube, activated by 8,000 volts, in which helium gas was used to cause the radiation to kill the virus of cancer and other viruses. This is a standard X-ray tube converted with the helium gas so that it could be used, and this shows the change in the resonant frequencies to get different intensities of the light. Now we're going back to the original photomicrograph of the cancer virus, and then the new one that I patented, that I copyrighted in 1955 it was. This is a bacteria called typhoid, Bacillus typhosus, in which the bacteria has 3 viruses, one at the bottom, which you see, one at the side, and one at the top. When the polarity is negative in the body, the virus remain in the bacteria, but when it gets too negative, they're compressed and they're extruded from the bacteria. When it's positive, well, they remain in the bacteria and there's no disease. The feelers are shown on the lower right-hand portion of this picture. That's done with a stain that Rife developed to show the feelers. This was a dinner meeting at Dr. Milbank Johnson, MD's home in Pasadena, honoring Rife and Dr. Arthur I. Kendall of Northwestern University Medical School. And this is the 40 doctors that attended that dinner. And they had Dr. Rufus von Klein-Smith, president of USC, was there. And his university was used to sponsor a clinic in 1934, which cured 16 hopeless cancer cases. These pictures were taken after Rife passed away in 1972, showing the universal microscope again. Lower portion of it. That's one of the 6 ray tube instruments that were built by Allied Industries, which I owned. And these instruments were built by Kennedy of San Francisco in 1920. This microscope I designed and built for projection of the viruses, bacteria, and worms and so on a slide 10 feet away. It also has a front screen which you can see the rule gratings being projected on the front screen. This projection microscope is available at $10,000 apiece. One of these instruments is used in the Los Angeles area now in research.